Hey, B here! We've covered a lot so far in this unit about the angles in triangles. Now let's take a look at the side lengths of triangles and see how they are related to the angles. Let's get into it. Here we have 3 triangles, all labeled with their angle measures and side lengths. I'm wondering whether there are any interesting patterns we can discover. Let's start by ranking the angle measures from smallest to largest and the side lengths from least to greatest as well. We'll do the first one together. For triangle ABC, we've got angle B, which is 43 degrees, then angle A, which is 64 degrees, and then angle C, which is 73 degrees. Easy enough. And the sides? Side AC, which is 5 units, then side BC, which is 6.6 units, and then side AB, which is 7 units. Pause and rank the angles and sides from smallest to largest for the other 2 triangles. Compare your work to mine and correct any mistakes before we move on. Now that we have that sorted, do you notice anything interesting about the sides and angles? Pause and take note of any patterns you see in your guided notes. You might have spotted something I noticed too. The smallest angle is always across from the shortest side. And the largest angle? You guessed it, across from the longest side. This isn't just some neat trick. It's a rule that is true for every triangle. Let's try this idea out with a few different examples. First, we have triangle MNO, and we want to write the sides in order from shortest to longest. Where should we begin? If we can put the angles in order from least to greatest, we can use that information to put the sides in order. But wait, I only know 2 of the angles. We know the measure of angle M, which is 35 degrees, and we know the measure of angle N, which is 65 degrees. How can I determine the measure of angle O? That's right, the sum of all the interior angle measures is 180 degrees. 35 plus 65 is 100, so the third angle must be 80 degrees. Okay, now that we know all of the angle measures, we can order the sides. Take a moment to write the sides in order from shortest to longest. First, I wrote the angles in order from smallest to largest to help me determine the order of the side lengths. Since side NO is across from the smallest angle, angle M, it is the shortest side. Angle N is next, and it is across from side OM. And finally, side MN is across from the largest angle, angle O, so it is the longest side. And there we have it. Even though we don't know the actual side lengths, we know how they related to each other. In this next example, we have some information about the side lengths of triangle TUV, and we want to write the angles in order from smallest to largest. Well, I can tell that side TU is the shortest side, and I know that the smallest angle is across from the shortest side, but which angle is that? In the last example, I could look at the triangle to determine the angle and side relationships, but there isn't a triangle to look at here. I wonder if we could use this information to make our own sketch of this triangle? Let's try it out. First, we know it's a triangle, so let's sketch one. It's okay if the side lengths aren't exactly to scale. We're just making a rough sketch so we can visualize this information. Next, this triangle is called triangle TUV. So I know that the 3 vertices are T, U, and V. Now that we have a triangle, let's label it with information we have. Side TU is 4 centimeters, side UV is 6 centimeters, and side VT is 8 centimeters. Great! Now we have a visual to help us. Pause now and order the angles in triangle TUV from smallest to largest. Side TU, which is the shortest side, is across from angle V, so angle V is the smallest angle. Then angle T, and finally, angle U is the largest. Great work! Today, we learned that in triangles, the largest angle is across from the longest side, and the smallest angle is across from the shortest side. We also used those facts to order the angles and sides of a triangle and determine possible values for angle measures and side lengths. When you finish these guided notes, you can move on to the online practice. And remember, math is everywhere. Keep exploring.
Hey!